Hello and welcome to podcast.init, the podcast about Python and the people who make it great. You can join our community at discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, propose show ideas, and follow up with past guests. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. We also have a new sponsor this week. Rollbar is a service for tracking and aggregating your application errors so that you can find and fix the bugs in your application before your users notice that they even exist. Use the link rollbar.com/podcastinit to get 90 days and 300,000 errors for free on their Bootstrap plan. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, and now Google Play Music just launched support for podcasts, so you can check us out there and subscribe to the show. Please give us feedback. You can leave a review on iTunes or Google Play Music to help other people find the show. And don't forget that we have 2 tickets to the Open Data Science Conference in Boston, which is happening on May 21st and 22nd, to give away. In order to enter, just sign up for our newsletter at pythonpodcast.com. Also, if you use the code EP, you will save 20% off of the ticket price. If you decide to attend, then let us know. We'll see you there. Your hosts, as usual, are Tobias Macy and Chris Patty, though Chris is going to be joining us a little later on today. Today, we're interviewing Anthony Shaw about the Apache LibCloud project. So, Anthony, could you please introduce yourself?
Hey, everybody. My name is Anthony Shaw. I'm calling from Sydney, Australia, where it's a little bit later in the evening here. I'm on the Apache LibCloud Project Management Committee. So that's basically one of the governing boards for the project. And I'm here to talk about Apache LibCloud and have a good conversation about Python. So
great. And how did you get introduced to Python?
It was a little abruptly, actually. I come from more of a C++ background. I've been a developer for about 10 years now. Spent most of my time recently with C#. And mid last year, I was on a trip in Seattle to visit Microsoft. And I was supposed to fly to New York for the weekend. And I was actually ill, so I ended up being stuck at the hotel for the whole weekend with nothing to do, and there's not a whole load to do on the East Lake. So basically, I thought, okay, what am I going to get up to? So I figured I'd sit down and learn Python because it'd been on my to-do list for a while. And I picked up the Apache LibCloud project because that looked like a great place to start. And the company I work for, Dimension Data, we have our own public cloud, and we didn't have a driver. So what I set about doing over the weekend was trying to learn the language, and to do that by trying to put together a driver for LibCloud and see how that was done. So that's kind of how I got introduced to it. And sort of hacked around with it for over the weekend. It's a pretty straightforward language to get used to, actually. I've worked with a number of different languages in the past, but it was a bit of a shock coming from a C-ish space, and then going to something that's white space significant and losing all the braces and stuff like that. But once you get over that, it's very easy to learn. And then when I got back to Sydney, I went through a series of training modules on Pluralsight. If anyone uses Pluralsight, I really recommend Austin Bingham and Robert Smallsh's talks on Python. There's about 8 hours worth of training content on Pluralsight by both of those guys, and they were excellent because it taught me not just syntax, because that's important to get started, but how do Python developers do things. And that's what I really wanted to know was, I don't want to write Python like a C programmer. I want to write Python like a Python programmer. So what kind of conventions are different? What do they do? And that was a good place to start for that.
For anybody who's not familiar with it, can you explain what the LibCloud project is, and if you're familiar with the history, how it got started?
Yeah, sure. So LibCloud is a Apache top-level project. It's written in Python. It's a class library that includes... It's a combination of things, actually. It's a client library for multiple clouds. I say multiple, there's on the compute side, so you've got the other things like Amazon and Azure, and providers like Joyent and DigitalOcean. In total, there's about 52 different cloud providers. So it's a Python package that has the client libraries for those. And we don't depend on those. We don't depend on each provider's own Python library. We've basically written our own implementations of an AWS client, an Azure client, a Giant client, and all of those. There's zero dependencies. And it also has an abstraction system where you can basically ask LibCloud to give you a class implementation to get information about compute and provision compute. So the focus of the project is to try and make all clouds look the same, as hard as that sounds, and to provide that in a way that's fairly seamless and dependable without too many surprises. That's kind of what LibCloud does. It was formed fairly organically by a startup called CloudKick, which I think was in 2008, 2009. There's an Apache member called Paul Querner who kicked that off. And CloudKick was acquired by Rackspace. And just before the acquisition, the team that was originally working on it, they were working in Python, which is why it was originally done in Python. And they decided that actually this bit of IP we've got around this generic cloud abstraction is pretty cool. Maybe we should separate that off and make it a separate project, because the monitoring thing and the cloud abstraction, sure, they go together, but actually there's a single responsibility principle on the abstraction side. So they kind of separated that off, put it as an Apache incubator, which is like Apache's, before you become a big project, before you sort of graduate to big boy school, they put you in the incubation space. And it was sat there for, I think, about a year and a half, where different mentors from the Apache Foundation basically helped them progress through that.
How much overhead does using LibCloud impose versus native SDKs for performance-sensitive APIs like block storage?
Yeah, that's a tricky one. I'd say that so we have a storage abstraction driver. Compared with something like, if you're talking about Amazon, compared to something like Botto, it would probably be similar in terms of performance. So we use a similar principle, streaming data from the file objects and writing them to the APIs. And we did have our own HTTP library that was written originally back in 2009. We're just working on replacing that with the requests library at the moment. Back in 2009, it didn't exist. So the guys that were developing it had to write their own. But now we've got the option of using requests, but putting that functionality in. And that basically gives us a more direct stream to read and write raw file streams. So if you are using object storage like S3, for example, then it would increase performance significantly in the new versions. In the older versions, again, really, we're still using Python data streams. So we're not sticking anything in the middle.
And what are some of the design patterns and abstractions in the library that allow for supporting such a large number of cloud providers with a mostly uniform API?
It's a really hard problem to solve, actually. Each provider has a very unique API. Each provider obviously wants to differentiate themselves from another. So if you just compare simple things like OpenStack and VMware vCloud, for example, then they want to differentiate themselves against each other. Therefore, they have different functionality, and therefore they have different APIs. So I think it still remains a challenge for us to figure out how to abstract these things away. Luckily, Python makes that pretty easy compared to a more strongly typed language. So there are a lot of benefits to being able to rapidly construct and iterate through dictionaries in Python, which you would otherwise find quite hard to do in a language where you don't have dynamic types. I think we'll talk about JCloud maybe later, but that's another project written in Java. And it's really interesting to see two languages try and solve the same problem. And something like Java, where there's a sort of lack of dynamic typing in Java, whereas in Python it's a bit more native. So what we really have the ability to do in LibCloud is provide a base class. So it's like a driver base class. So for compute, that would give you methods like list nodes, which lists the VMs you have, list networks, deploy network, deploy node, start node, stop node, delete node. So sort of basic functionality. Each driver then inherits from the base class, and if they have any additional arguments, then we sort of advise against using keyword arguments because it's quite difficult to document those. And in terms of how we generate our documentation, it's much preferred to have named keyword arguments rather than star quarks. Also, we have a number of model classes that come back from the driver. So if you say list nodes in the Amazon driver and you say list nodes in the Azure driver, then the list that you get back looks exactly the same. So you get a list of node instances, and the node instances have the same properties, and that is the name, the ID, the location, and the state in which it's in. So there's standard properties on the class. That's like a standard model. And then there's an extended dictionary called extra, which allows each driver to put in additional information that's unique to that driver. So you can still pick out the extra stuff like, okay, which AMI was this deployed from, or, do I have any additional EBS volumes, or, more specific stuff for like Amazon. And then we basically have a factory method that sits around the top of this. So you can say, give me a driver, and you can ask for a Rackspace driver and a dimension data driver and an Amazon driver. You can put those in a collection, and then you can iterate through them and list nodes across multiple clouds. So that's kind of where it starts to become really powerful. It's not just having a consistent way and a consistent set of models for interacting with different cloud APIs, but being able to put all of those together and actually see the whole picture. So what do I have in all of my clouds instead of just targeting them individually?
Given that there's such differing services provided by the different cloud platforms, do you face any difficulties in exposing any of those additional capabilities, such as Route 53 with Amazon, or maybe some of like the Google Container Engine, anything like that?
We've separated things into different base drivers. So at the moment we have compute, and we focus on whatever is as a service. So anything that's provided as a service, we focus on that abstraction. So compute as a service, I think, is fairly well known, and that's what the driver is really known for. We also have DNS as a service. So we support Route 53, and we support providers like GoDaddy. I think there's about 20 different drivers in there. The Azure DNS as well. So we then have storage. So that's for your object storage, like S3, Azure Blob Store, and more sort of native stuff, as well as Ceph and the OpenStack Swift, I think it's called. We also have Container as a Service, which is a new one. So that's for Amazon's Elastic Container Service, ECS, as well as Google Container Engine, or just Kubernetes directly. So we kind of have a container as a service abstraction driver. And also we have load balancer, which is a more specific one. And then anything that kind of fits outside of that, I guess, which is a bit more unique to a particular provider. So let's say Amazon, their simple queuing service, for example, I think it would still be very hard for us to create a queuing as a service abstraction API, because at the moment there are only maybe a couple of providers that have that, and their services are really different. So we've really focused on places where there are similarities and where we think there's value in providing an abstraction. And that's kind of been the focus of the project.
For those kinds of additional services, do you recommend to people that they just use the native cloud drivers, like for instance the Boto library?
Yeah, and I think that is the case as well. Just looking at the popularity of the two, so however it's pronounced, the Boto or Boto. Sorry, I'm English and I'm living in Australia. My accent's got so confused over the last years. I was looking at it today. Actually, there's a PyPy ranking website, and it's the 10th most popular package on PyPy. So it's not just popular; it's one of the most popular Python packages. So we know that people are using it. And yeah, if you want to orchestrate the queuing stuff, if you want to orchestrate Lambda, for example, then yeah, of course you should use a native system. One of the things that I think is a bit different about LibCloud is that we try and treat our cloud providers the same, and the reason for that is various things. One is that when you're trying to write a portal, like a multi-cloud portal, and there's a few kind of examples of this, then what tends to happen is these multi-cloud portal development companies sit down and they go, okay, now we have to code against Amazon, and we have to code against Azure, and then we have to code against OpenStack. So, and I've seen this time and time again. They sit down and they develop these libraries. They use the native client libraries, and then they have to write a whole bunch of custom code to normalize the data that they get back from each of the APIs. Then a customer comes to them and says, "Oh, we really need DigitalOcean as a provider," and they're like, "Oh, great, okay." Now we have to go and do the same thing again. And where kind of LibCloud comes in is to give them that abstraction out of the box, but also allow them to then just focus on the over-the-top stuff. So, there's no value in these companies writing their own abstraction APIs when, especially if they're using Python, because LibCloud's done this for a number of years. We support pretty much every cloud provider you can find. I mean, on the compute side, there's 52. On the storage, I think we have about 20. On DNS, there's about 18. So we cover off pretty much every major provider. The APIs are kept very up to date. They're very well maintained. And I think, like I said earlier, it's a client library. It's not just an abstraction library. So it includes implementations to talk to all of those different clouds. We don't depend on individual packages to do that. So one of the risky moves in either building it yourself or depending on different libraries and packages is the versioning side, for example, and also just creating this massive dependency tree. I think if we'd have decided early on in the project to say, okay, we'll use Amazon's Python library, we'll use Microsoft's Python library, we'll use X company's Python library. I worked out the other day that we'd have about 500 package dependencies in the project. Just the amount of maintenance to do that would just be insane. I like I said earlier, I worked in C# for a long time and still do. And there's this what they used to call DLL hell.
Yeah.
If you remember that. But we now have this thing called NuGet hell, which is NuGet's the .NET equivalent. I don't know if either of you guys work in .NET, but NuGet is the .NET equivalent of a sort of package format, like an egg, basically. And once you create the bindings, it's only for a specific version. In .NET, we get these implementations where we've got all these different packages, and then eventually somehow we've got 500 dependencies, and one dependency needs a different version to another one, and they argue about which version is the right one. It just gets into such a mess. So it's not hugely popular, to be honest, when new people come on board to the project and they say, "Oh, I don't want to write my own client library from scratch. Why can't I just use this?" But in the long term, for the health of the project, it's really important, because we can't guarantee that these Python libraries are going to get maintained by people. So that's kind of been our focus.
Right. And I can imagine that there are also a number of cloud providers that don't even necessarily have their own native driver for their particular platform. So something like LibCloud might be the only option in the Python space.
Yeah, and I don't want to name names, but it's not that they sometimes they have them, but they're not written by Python programmers. Like I said earlier about wanting to write Python like a Python programmer, not like a C# developer.
Yes.
There are a number of cloud providers who have auto-generated Python, or they sit down and basically port a Java library to Python, and it's horrible. It's really nasty to use. So.
It's definitely not too hard to write Java or C or some other language in Python. And for somebody who's actually used to writing Python, it's definitely pretty painful trying to interact with those libraries, because there's just a big cognitive gap in how you think the problem should be solved versus how it's actually being done, or the APIs that are exposed.
Yeah, absolutely. I think people who are new to the platform cringe a little bit at how often Python programmers use the term Pythonic, but it actually is there for a reason. And it is, as you say, it's kind of a way of thinking about things, and it shows in the code you write.
One of the first things that hit me actually was the lack of a switch statement. So I kind of got to a point where I was like, where's the switch statement? Why is there no switch keyword? And then I sort of Googled it, and code by Stack Overflow, which is always a bad idea. But then realized they said, you can do if, elif, but this is not a very Pythonic way of doing it. And I'm like, what does that mean? And I'm like, and then you kind of see better examples and better patterns. And the argument actually, this is probably quite a good Stack Overflow, instead of just here's a really lazy copy paste a snippet of code, was the top rated answer was, if you need to use a switch statement, you're probably doing something wrong. and try and look at your patterns again, because I think you've ended up in the wrong place.
Yeah, one of the more interesting approaches or patterns that I've seen and used for attacking the particular case of needing to use a switch statement is actually using a dictionary where each of your cases in the switch statement are a key in the dictionary, and then the function that needs to be executed is stored as an object as the value in the dictionary.
Yeah, I think we actually use that pattern in a couple of places, which is so much tidier and so much easier to read as well. Our package, we insist on PEP 8 compliance, and it's part of our CI as well. So, we do force shorter line length, and that helps stop some of the nesting, which, especially in C#, gets to crazy levels. Like, all of the developers that I work with on C# have these huge, big widescreen monitors because there's such crazy levels of nesting in all the functions.
Yeah, one of the nice things that I've found when actually adhering to PEP 8 is that if you do find that you're running out of line length, it usually means that you're nesting too deeply and you need to break some things out into their own function. So you touched on it briefly with mention of the JCloud project, but how does LibCloud compare to similar projects in other languages, such as JCloud, as you mentioned, or the Fog gem in Ruby?
Yeah, JCloud is again an Apache project, and I think they have a very similar ethos to LibCloud. We actually more recently started talking to them and trying to sort of start some collaboration exercises. Java, I guess there's a few differences between LibCloud and JCloud, and they probably speak to the differences between the languages. They have much stricter contracts in terms of the base drivers and the interfaces that are provided on the Java side. So it's a bit harder to, I guess, bend the rules a bit. So on ours, for example, if you say list nodes, let's pick GCE, so Google Cloud. When you say list VMs, you need to provide a project ID. If you're doing it for Amazon, it's a bit more generic, so you can just say list nodes. So for list nodes on our side, then we can, just have an extended argument on the list nodes method. And then if it is Google, then you can include that as a keyword argument. That's easy to do in Python. On Java, however, if you're implementing a contracted interface, then you can't just add additional arguments on the method. So that's where they've kind of had to design things a bit differently. And I do think that makes it a bit harder for them to add new drivers. I know there's a bit more overhead. So in terms of the two packages, theirs is probably stricter in terms of the contracts, but they have fewer providers. In terms of functionality, they don't support some of the stuff that we do, like backups and containers. Fog is actually a bit different. It's more of a client library rather than an abstraction library. The Fog gem does include clients to talk to a number of different clouds, but it doesn't really provide a generic model or any contracts. So depending on which provider you talk to, you basically get different responses back. And some of them are normalized, some of them aren't. So that's probably the difference between Fog and LibCloud. Both LibCloud and JCloud are Apache projects as well, so that's another differentiator.
And LibCloud has way better documentation than Fog. I realize that's like maybe a small thing, but when I had to learn how to use Fog, and I got told about 15 times to use the source, Luke, which, Fog is a non-trivial software package, and sometimes using the source can be rather like pulling teeth, even when the source code is good, right?
Yeah, I think it was talked about in a past episode, actually, the differences between the Ruby packages and the Python packages in terms of documentation level. But I found the same thing. I've tried to use Fog to write, actually working on it at the moment, to do a client library for the provider that I work for. I found the same thing. Like, the documentation was kind of like, read the RTFC, or what I call it internally, but I'm not going to spell that out. But with ours, I think we focus on the documentation, and as part of our PR process as well, we do require that people include documentation, and that is pretty strict. And obviously DocTools makes that pretty straightforward, because we can test that as part of our build. We actually do check the docs and also build the docs. So that's really cool.
So you briefly touched on the inspiration for the choice of Python being the fact that the company who first created it was largely a Python shop. But if you were to make the same choice again, if you were starting the project today, do you think that you'd make the same choice of using Python as the language for it, or do you think you would use something else?
Yeah, I do a number of other projects at the moment. I've had experience with PHP in quite a lot of detail. With so some of the sort of more weakly typed languages like JavaScript, PHP. I've just been introduced to Ruby recently. In terms of functional programming, I've stayed well away from that for now. I don't want to cover that off unless I get ill again and end up locked in a hotel for 4 days. But yeah, and then on the more sort of strongly typed open side, C# has been my main experience in C++. And to be honest, I would still pick Python because the task that we're doing isn't a particularly clean programming pattern. We're kind of acting as a facade in some places and a mediator in others. And we have to talk to these different APIs, which all behave kind of differently. Some of them have weird behaviors. Some of them are consistent. And, it's a tricky problem to solve. And I wouldn't say there's a particularly clean way of doing it. You're not going to write the absolute perfect code writing a project like this. And the thing I really love about Python is that just doing dynamic modeling is refreshingly simple. And doing it in other languages, C# is actually a little bit easier. They added the dynamic type in version 5 of C#, I think it was. Which makes things a lot easier. And they mainly did that because, people were starting to use JSON libraries. And, when you convert something from a JSON document to a local object, then, what do you get back? In C#, you can't define the fields at runtime. So they actually had to create a dynamic type. Java, I don't think, has done that yet. And C# still is complicated. Once you got it in a dynamic type, it's hard to then port that to something more concrete. And you have to, if you want to do it as a solid type, then you have to put all these attributes around all the fields, and the matching has to work, and you have to include all the formatters and stuff. So, I've done it in C#, and it's overhead, and I'd say it's hard work. And it was just refreshingly simple to do it in Python. And that's one of the things that I was so surprised about with the language was that I was like, because I had a fairly bad experience with PHP because I kind of came in the I don't know if there must be a fair few PHP programmers on the call in the 4 days when register globals was a good idea, which I don't think we should have ever been the case. So if anyone's ever, I'll explain what register globals is for some of the non-PHP developers. But imagine you're writing a PHP page, and you can basically override any variable on the application just by putting that variable name in the get parameter or in the post body, and then basically setting the value. So, basically it's just a really lazy way. Anything that was in get or post would basically get turned into a global in your application scope. And if you forgot to name or if you forgot to override that global at some point in the scope, basically an attacker could override any of the variables in the local scope just by changing the URL. Anyway, I digress. So I got burnt in a number of places on PHP, mainly in the security side of things. So I worked as a sysadmin for a while, and just fixing PHP, really badly secure PHP apps kind of burnt me and put me off weakly typed languages for a while. Perl, I got put off Perl for similar, not the same reasons actually. I think the security side was a bit stronger, but just obfuscated code. Writing in Perl can be fun, but I found that I had to Google the same thing over and over and over again, to the point where I was thinking, is this really intuitive? Like, if I've had to do it 9 times and every single time I've had to go back to Google, why isn't this sinking in? I'm not, I'd like to think I'm not stupid. Is it just not intuitive? And that's the conclusion I came to, was that maybe I'm just not of the right mindset to be a Perl programmer because, I just find this really hard and it's not fun. And it definitely wasn't enjoyable. So
it's definitely not fun. Any language that forces you to unpeel your own, subroutine method call parameters from a stack cannot be considered intuitive in my book.
Yeah, and maintaining other people's Perl code is like, I wouldn't want it on my worst enemies. It's it's like a game that they play to try and make their code as obfuscated as possible. So
I didn't realize that was an option.
Yeah, maintaining and Perl, no, they don't really go together. So no, I didn't come on here to bash other languages, but I'm doing it anyway.
So bringing it back to Python, which versions are supported and what challenges has that created?
Yeah, because the project has been running for, I guess, back in the 2.5 era, then we got up to 2.7, and then the questions around the sort of Python 3 came up. The chair, our project chair, Tamaz, who has, if you go and look on the Git graphs, you'll see he's the one who's written sort of 80% of the code for the library. He does the work of about 5 people. It's amazing. He did the hard work actually quite early on, and we were sort of one of the first big projects to port to Python 3. So we currently support, I'm going to say 2.6 up to 3.5. I can't remember strictly whether we support 2.5. If it works, then good for you. But if it doesn't, please don't come and ask for help, because we're trying to phase it out. And the question at the moment is coming back about 2.6 because, dealing with 2.7 is so much easier. For those who are listening and I guess aren't too familiar with the differences, a lot of the nice functionality that gets added in Python 3 then kind of got backported to 2.7. But that stuff wasn't really available in 2.6. So we kind of program the library like it's 2.6. And we also have a utility library that's part of the package that's called Py3. And all of the drivers basically use this library, and it does the switch out. So it basically discovers which version of Python you're running, and then we switch things out. So we have our own version of base string, and then depending on which version of Python you're using, we switched it out for a Unicode and string as a tuple, or we just use a native string type. So we basically have a Python 2/3 abstraction utility module package, I guess you want to call it, that's part of the code, which is really cool. Actually, Tamaz put that together. And that makes it a lot easier for people who are used to Python 3 coming into our library and trying to develop on it, as well as people who are more used to Python 2. So yeah, we support up to the latest and greatest. So 3.5 definitely is a supported version. We might consider dropping 3.0 and 3.1 in the future, just because there were some crazy issues with those. But.
So it sounds like you've implemented your own version of the 6 library inside of LibCloud so as to reduce your dependencies even further.
Yeah, we did. More or less, yeah. We try not to do too much string comparison, so it should be avoided if possible. And different APIs as well. Some of them don't support Unicode and some of them do. So you also need to be careful about not just having Unicode strings in run space, but actually whether the API you're talking to even supports it. So that's another challenge.
And as a Python project, I'm assuming that your main method of distribution is via the Python package index. So I'm wondering what your opinion is on the state of PyPI as a package index and what statistics are most useful to you, and wondering what else, if there's anything else that you wish that you could track.
Yeah, sure. So I think it's a great platform. Like I was saying, sort of comparing it to .NET, they've got only recently really NuGet.org, which is their sort of version of PyPI. I use it just to kind of keep track of download count against particular versions, and also we obviously use it for packaging and publishing. There's a few kind of things. I think it's great as a consumer. Like if you're just pulling down packages, then it's a really useful tool. But if you're publishing packages, I think it still has a lot to be desired compared to Gem, compared to NuGet.org, compared to NPM, for example. Like I don't know. So I know that version 0.14 is really popular, just by looking at the download count, but I don't know why. Like, I don't know whether it's because a particular project has it in their requirements file, or you know why that is. Like, I'd really like to know more details about what versions of Python people are using. Like, we talked about, dropping 2.5 support, and I'd like to be able to go, we've only had 10 people use Python 2.5, download the package from Python 2.5 in the last year. So therefore, we're going to maybe upset 10 people, but that's not the end of the world. Maybe we can find out who they are and email them, or just put a note online. Whereas if we say we want to drop 2.6 and we find out that 30% of our users are using 2.6, then, that would be a stupid decision. And we're just left to guess, really, or we're left to ask users. But the thing is that because it's a module, then sometimes people don't even know that they're installing LibCloud because it's part of another project. So they wouldn't necessarily want to give us feedback, or they're not on our mailing list. So it's hard to get in contact with them. And for something like NPM, for example, you can see, okay, this package depends on these packages, these specific versions. And I'd like to know who's added us in the requirements file and which versions have they picked, and can I get in contact with them and say, hey, do you guys fancy using the newer version? You get these features, and just checking we haven't broken compatibility and things like that. So that would be really, really, really helpful, is to get download count per Python version, just so we can kind of get that metric. And I'm sure the PSF would value that as well, like getting usage statistics of different Python versions. And we talk about the reason for not switching to Python 3 is mainly because you end up coming across a dependency that doesn't yet work in Python 3. Like, I think if we knew who depended on what and which versions are being used, that picture would actually be a bit clearer. So I would love to see that, and definitely other platforms have put that in place. So.
Tobias, you'll have to refresh my memory because it's too early in the morning here. What was the name of the gent that we spoke to in the last episode who works on PyPy and is working on Warehouse, the new version?
I was just going to say that Donald Stuft was his name, and I was going to say that this conversation is particularly relevant given our previous conversation, and it certainly sounds like a good opportunity for some open source contribution to anybody who is so inclined to add that capability to the Warehouse project, and also potentially pip, depending on where those statistics would be pulled from.
Yeah, definitely. I mean, for those who might have not caught the last episode, they are actively seeking contributors for the Warehouse project, which is the new version of the PyPy website. So if nothing else, even if that's not where this particular change would go, it might be a great way to engage with those folks and sort of figure out how you can pitch in and maybe get this change made. Because I agree, I think that would be useful to a lot of people. So could you walk our listeners through the under-the-cover process details of instantiating a compute instance in, say, Azure using LibCloud?
Yeah, sure. So the starting point is that you obviously install the package and import the module. We have I don't know if it's a Pythonic term to say a factory method. Is that a Pythonic word?
Yes.
I spend too much time in C#. It's really a Java thing, I think. We have a factory method called getDriver, and we have an enum called provider, and that basically lists out all the different providers we support. So you call getDriver and you say provider.backspace or provider.ec2, for example, and it would give you back a class instance, a class object, and then you would instantiate that by calling the initializer. So you can call getDriver, you get back a class object, you can instantiate that, and then you know what methods you're going to get on the driver. So you're going to have list nodes, you're going to have create node, list networks, start stop node. So that functionality is going to be there. For DNS, for storage, it's all consistent, it's all the same. So you have a factory method, and you call that with a provider enum, and it gives you back the relevant driver. So that's basically all you need to do. If you want to create a node, then there's a method that's part of each driver. called create node, and it has a set of standard ordered parameters, and you can call those and give it sort of the name and the address. Depending on the driver, you might then have additional keyword arguments that you can include for things like scheduling for GCE, for example, or what additional EBS volumes do you want to use. Also, we do support things like sizing. So for Amazon, you can obviously do list sizes, which is a node feature that works against other cloud providers that have a notion of sizes as well. And for things like SSH keys, any of the providers that support keys, you can include a key in the create node. So we've created consistency amongst the providers that have this notion of keys, which is SSH keys, which is quite common, and the idea of a sizing. Not all of them do though, so maybe about 30 or 40%, I think, of the drivers have a sizing idea. So you do need to know a little bit about the cloud that you're using, or it will just default back to whatever we think is appropriate. So if the drivers provide default values, we'll include those. So once you do create node, you basically get back a node class instance, and then on that instance you can call methods like start and stop, and you can then use that to add it to a load balancer. So you'd use the load balancer module and you create a load balancer. So one of the cool things is that because the classes are consistent across the drivers, so in terms of the structures that you get back, in terms of the fields, so they're consistent, so that you can mix and match across the tools. So we talked about Route 53 as a DNS, for example. If you wanted to use Route 53 for your DNS, but you wanted to use Azure for your VMs, you could actually cross-pollinate those. So you could use the Azure driver to create the node, then you could pass the node to a Route 53 instance and say, create an A record for this. Or you can do the same for load balancers. So any load balancer provider that supports public addresses, you can give it a collection of nodes, and they could actually be from different clouds. So that's another example where we kind of not just say treat the clouds the same, but actually create a solution that allows you to span services across multiple cloud providers.
That sounds really powerful. I mean, I've definitely seen LibCloud for the purpose of avoiding vendor lock-in, so being able to migrate your workload between different cloud providers, but being able to so seamlessly orchestrate resources between the different providers just by passing around objects within the LibCloud library is pretty amazing.
Absolutely. I mean, the idea of being able to sort of take the best of breed from each service, use Route 53 because it's the most evolved DNS provider, and let's use compute instances from Google because they're cheapest, and that's awfully cool. It's a very compelling value proposition.
Yeah, I'm hoping that someone will put this together, and if they do, please send me a link to the code. But there's been this concept of a storage, basically like a storage broker. So our storage client works across all the major object storage providers, and it would be awesome if somebody would write an app that would take a directory and then sign up to every free tier around, and then basically just spread your files across all the free tiers. So you can just have a few gigs here, a few gigs there, and then just keep manipulating that free tier.
That's really funny. I think you're not the first person to have that idea, but I think that LibCloud may be the right infrastructure at the right time to actually implement it. So that is kind of a neat idea. Unless you're Dropbox and or Google and or all these other providers, because perhaps the idea of having a utilize people's free storage everywhere abstraction is perhaps not so ideal for their bottom line. But for end users, I can certainly see it being a boon.
Yeah, exactly. And there are other advantages as well. Like you mentioned lock-in. So I'm going to talk about this quite a lot at the moment because I guess it's a concern of mine, not just from an open source point of view, but in terms of the more sort of open platforms. And that's that, we talk about vendor lock-in or cloud lock-in, but I think it's actually becoming a real issue is that people kind of default to AWS. I think it's a great platform. It's really awesome. It has a load of functionality, but it just becomes now the default stance. And the thing that worries me more is that people's skill set or their applications will be bound to the AWS architecture. And then let's say you leave that company and you go and work somewhere else, and you're working in a purely research environment, like you're working for a not-for-profit, or you're trying to do everything off your own back, and you want to run things on your laptop. Then all of a sudden you're not going to have access to all those APIs, and your application stack's not going to work. Or it's like if you kind of bound yourself into a paid service, then you get what you wish for. So
no, I totally agree.
So that actually brings up an interesting question. Does LibCloud have any sort of drivers that would support abstractions to allow you to target things on your local machine? So for instance, if you needed to provision DNS, maybe just have it edit your Etsy hosts file, or if you needed to access allocate storage, just have it placed directly on your hard drive.
I'm not sure about Etsy hosts as a buy and replacement, but I'm not sure actually whether we do support that. In terms of compute, definitely. So we have support for libvirt, which is a virtual driver, which can write to KVM. So you can use that for OpenStack. If you somehow manage to run OpenStack on your laptop, then fair play to you. But you could use that for containers. We support Docker. Local, like if you're running Docker locally, which pretty much everybody does, then you can use that. And on the compute side, there's KVM, the VMware, I can't remember the name of the thing now, the virtual desktop, I think it's called, and VirtualBox. Yeah, you can run all of those locally. So yeah, I've used it for a number of things where I've got some spare hardware lying around, and I use LibCloud as to kind of orchestrate that. And then when I'm ready to promote it to a public cloud environment, then I'll basically use the same code to do the same thing.
Yeah, having the same abstractions and same setup for local as well as production development is definitely a important capability and one of the larger goals of sort of DevOps as a whole. So having LibCloud as an option to support that kind of workflow definitely makes it even more appealing than it already is. So does LibCloud have any native support for parallelization, such as for the purpose of launching a large number of compute instances simultaneously?
Yeah, it does. So I think there's a note somewhere in the documentation saying that the library is not guaranteed to be thread safe. I'm not sure who wrote that and what the reasoning was. I've never tried to to do it in that context. So I don't know how badly it would blow up. But if you look at the cloud providers, then we have each time you implement a driver, you pick a type of connection, and we have one called an async connection. So providers where you'd want to provision a number of nodes simultaneously, typically what you would do is if they have an asynchronous API that you can call, so you can say provision a node and it gives you back a job ID, then you can use just a standard connection and keep polling the job ID. Just typically what people do. And the other option is an async connection, which does a lot of that work for you. So you wouldn't necessarily want to call all of those in a thread. Normally what you would do is create a job queue or a job list, and provision the nodes, because the cloud provider does that work for you of provisioning the multiple nodes at the same time. The other thing I've seen done in some drivers is they basically have a callback. So you can say wait for state. So you could have a list of target nodes you want to deploy, and then for each node you just say wait for state, and then just create a separate thread to do that. So that would be another way of doing it.
Yeah, that was another question I had, is wondering whether LibCloud exposes any events within its lifecycle of communicating with the different services, or if it has support for callbacks for being able to string together different operations without having to necessarily do the polling on your own.
Yeah, one of the drivers does have some callbacks, but I'd still say that the cloud providers are a bit behind in terms of streaming event APIs. So it's probably a more recent thing actually that we're kind of stepping away from this idea of just keep calling the API and checking for differences. I was working recently with Slack, the Slack APIs, and they have a streaming API, which is really cool. So you can basically just subscribe to it and pull out the events from the remote service. So if the cloud providers were to start doing that, then I think that's something we could then leverage. But until then, we'd have to create some sort of polling mechanism, and each cloud provider is different. Like most of them don't give you job IDs. You just got to keep asking whether your node exists yet, and then maybe it might say yes. It'd be tricky for us to do that.
And what does it mean to be an Apache project, and what benefits does it provide?
So yeah, there's a number of advantages to being an Apache project. Well, it's really kind of being a part of the software foundation. And that's, if you kind of look at the core principles of Apache, one of them is community over code, which I think is the most powerful of all the principles. And that's kind of this idea that the intellectual property of a project, exists not just solely. So if you just look at the project and the worth of a project, actually, you think about how much the community is worth. And in our case, we have contributions. Maybe we close maybe 10 PRs a week, I think, at the moment. And pretty much all of them are from different people. So individuals come forward and they improve a particular driver, or they add a new driver. We added actually 3 drivers in the last week. So we got 2 new DNS drivers and a new storage driver. So the power of having a community out there that's constantly improving the project and recognizing that and protecting the brand of the project as well. So there's a rule in Apache that if it didn't happen on list, then it didn't happen. So you don't have individuals in back rooms making decisions where everyone doesn't have a say. And I think that's quite important. It's not just about the brand, which is important, which is good. Having the Apache brand kind of gives the project a bit of a kudos. But Apache is, I think, the majority of Apache projects are Java projects. So I'd say the Apache brand isn't as well known in the Python community. They kind of think there's a couple of major Python projects, but they mainly think of the web server and things like Solr and those kind of tools. But there is this kind of idea that the community is the most important thing, or more important than the code. And also you can't buy influence in Apache. Like there's no, if you give the Apache Foundation $100,000, then you become, you get voting rights in a project. It's a meritocracy. So you start off as a committer, then you become a contributor, then you can become a member in future. And members get voted in by other members based on the good work they've done in the open source community. It's not like, it's not like one of these sort of political circles where it's who you know, not what you know. It's absolutely the other way around. So that is a really powerful thing. And I think that's what's enabled the project to run so consistently for so long and not had somebody come in and go, oh, can we buy the company that developed this? Or, can we buy this as a piece of IP, and what do we do with it going forward? And there's not all these external parties trying to buy influence in the project. We've kind of got this protection, similar to how you do with the PSF, actually, I think. But the ASF has been around longer. So.
What are some of the most notable projects that leverage LibCloud for interacting with platform and infrastructure service providers?
Yeah, so I believe one of you is a big fan of SaltStack. Who is that?
That would be me, Tobias.
Okay, cool. Tobias. So, SaltStack has a feature called SaltCloud. I don't know if you've used that.
Yes, rather extensively.
Okay, excellent. So SaltCloud is, well, I'd be able to tell you if PyPy would tell me. I don't know what percentage of our downloads are from SaltStack. I think it's a fairly significant amount. And I think they're the culprit for version 0.14, because somewhere on the SaltStack website it says this is the version you should use, but it doesn't say why. So SaltStack is a good case. The SaltCloud functionality, if you go and look at the driver implementations, I think all of them except for Amazon and I think OpenStack. OpenStack and Amazon, they used, in the OpenStack case, they used the Nova client library, and in Amazon they use Boto. But for everything else, it uses LibCloud. So SaltStack is a really cool one for us because it's a nice implementation of our library. They followed a similar idea that you can kind of define the infrastructure and provision infrastructure and pick a cloud. So they do use it for the compute side of things. And I recently added a new driver to SaltStack, again for the company I work for. So added support to SaltStack, and actually one of the other developers on our team did the work, and I handled the PR process. But that was really easy because we were already in LibCloud, and we just basically had to write some wrapper code and stick it in SaltStack. So if you've written it once, and this is the idea, if you've written a client library for LibCloud, then you get to take advantage of all the packages and tools and ecosystem that lives around our project. So SaltStack is the big one. Scala is another one, which is like a multi-cloud UI, like a management UI. Scala uses LibCloud for a number of different cloud providers. Another one very similar is Mist.io, which is a sort of mobile application where you can sign up and manage all your different clouds. Another one, Stackstorm, which is they were just acquired by Brocade last week, actually. So yeah, that's another one.
Yeah, we actually interviewed Tomasz and blanking on the other gentleman's name. It wasn't Evan. I want to say Patrick. But we interviewed them recently about Stackstorm, I believe, 2 or 3 episodes ago. So that was another good interview.
So could you describe how LibCloud could be extended to abstract away a new type of service that's not yet supported, e.g. a database?
Yeah, sure. So I've had to go through this recently, so I've still got some of the scars of the process. The one we introduced a couple recently. One is backup as a service. So I think one of the things we recognized is that, we have the compute, the load balancing, DNS, storage, and backup is supported amongst some providers, but not all of them. And some of the providers, so let's pick Amazon, for example, like people use EBS snaps as a way of doing backup and recovery. So that's fine, and you can orchestrate that. But what we wanted to provide was kind of like a backup as a service abstraction API. So what you have to do is mainly just research to start with, looking at the different APIs for the different cloud providers, see how they model their service, see what consistency there is amongst the different APIs, which is a really fun exercise. And I'd like to spend a bit more time sharing some of that with the community, because I'm sure there's probably some good feedback in there for the cloud providers about, why did you guys make this decision to make this so different from everybody else? And this has caused me so much pain. Or for example, just to give them credit and say, this is a really awesome API and thank you for making the documentation so wonderful. A lot of the time, actually, it just ends up being emails to cloud providers just pointing out the errors in the documentation, where they've got docs that have been written by hand and not from source. So, you kind of get all these mistakes in field names and stuff like that. So once you've done the research and you know really what the abstraction needs to look like, then you put together a core driver, and then you have to do implementations for, I think we dictate 4, just so that we're sure that you haven't coupled your design too tightly to a particular provider or a particular couple of providers. So we did this with backup, and we've added container as a service, which probably sounds a bit strange. I'll explain that in a second. Which again was a bit tricky because it's so new and the providers were so different.
I'll bet. And with regards to why do providers implement their APIs so differently, it just occurred to me as you were speaking, this is one of those instances where the rubber hits the road of, we like to build technology for technology's sake, but ultimately these things are businesses, right? And they're designed to make money. And it's not clear to me that the cloud providers would make any more money by enabling people to not be locked in to a given vendor, right? Like if all the APIs were standardized, then you could take your entire stack from one cloud vendor to another, and it's not in their best interest to do that, I wouldn't think.
No, and somebody did, I think it might have been NIST, tried to put together like a standard API or like an API standard document, and it was like 200 pages or something. And I think the cloud service providers, if they even looked at it, would have just shrugged it off and thought, we're not doing this. Like, we're going to implement it, and we're going to be the only. If we implemented it, we'd be the only people, and everyone would laugh at us and go, "Why would you waste?" Because it will cost them millions of dollars. Like I work for one of them, and you can't underestimate the overhead of developing this stuff, because you can't. It's not just one guy that can hack away in a room. You've got to make it absolutely rock solid, and you've got to roll it out to data centers all over the world. And there's people to train and documentation to update, and it's so expensive. So yeah, it just doesn't make any sense. So yeah, we have had that fun. And also I think it's been good because we've learned a bit about, how badly some of the APIs can be documented, and we've had a few bits of fun there. So, when they provide example responses and example requests in the API documentation, I would say 6 times out of 10, maybe they're wrong. Yeah, it's always, you can, so we actually pick it up in the PRs now. Like when people contribute tests into the project and they include fixtures, we look at the fixtures and say, this looks like something you got from the documentation website. Please can you include a real response, because, chances are it's probably different. But it's a case that someone updates the API and doesn't update the documentation, or the person who writes the documentation has never used the API, or somebody made a typo because they wrote the example JSON response by hand, and they put I before E, but they got it the wrong way around or something. It's happened so frequently, it's ridiculous.
Right. It's funny. I feel like I need to explain myself. You mentioned you work for one of the providers, and I'm just about to. I just signed an offer with, in fact, the big provider that you were talking about not wanting to get vendor lock-in with. So it's kind of like, yep, I can definitely see that standpoint. I think it's also true that AWS, I'm just going to say it, they have services that other cloud vendors haven't caught up with yet. So I think that's what makes it a tricky value proposition when companies are deciding what to go with and how to not get locked in. It's tricky because developers want to use the new services that exist in AWS, but nowhere else yet. So that's kind of a tension that, I think tools like LibCloud can help resolve.
Yeah, and it's not that I think people shouldn't, and I'm not speaking for the project, by the way. This is just my personal opinion.
We're all speaking. This entire podcast is our personal opinions and does not construe the opinions of any of our employers.
Excellent. So, I wouldn't say that you shouldn't use, the simple messaging service or Lambda, for example, just because you're stuck with it. Because I think there's some really cool stuff that's in AWS, and if it saves your company, if it saves your project time and it saves your project money, and there's no value in writing that thing from scratch, then yeah, of course you should do it. But I do also think people need to think about, what's your backup plan? Like if that service goes away or it doesn't become cost effective, then like what's your alternative? Which is kind of my main word of caution is that, make sure that you do have an alternative, because once you're in there and once you've been locked in, it becomes more costly to change to something else.
Absolutely. So could you talk a little bit about the cloud-oriented network services that LibCloud supports? Like, is it possible to create AWS VPCs, subnets, et cetera, using LibCloud?
Yeah, this is probably one area where we fall a little bit short still. We don't have a network as a service base driver or any kind of networking abstraction at the moment. The focus on compute was around nodes, and when the original design was done, I think Amazon was really the only one that had any kind of software-defined networking stance. OpenStack came along a bit later, and they introduced some of that functionality. Then they kind of rewrote it and redesigned it. So I don't think anyone really had the time to catch up and put together a networking answer. Each of the drivers implement the set of base methods, so things like list nodes, create node. Each driver then defines all their own additional methods. So, and these are all unique to each provider. So, like a VPC, for example, I know that VPC support is in the AWS driver, but it's not a method that's callable or abstracted upon. So, it's a extended method that's part of the driver instance. You can call it and you can talk to your VPCs. But not cloud agnostically. So you're kind of coupling yourselves to Amazon. But to be honest, that's inevitable. Like, I don't want to sit here and say, you can use our driver and basically like every cloud looks the same and you'll never have any kind of lock-in. Because realistically, each provider still has different ways of doing things. Like authentication, for example, every cloud provider has a different authentication mechanism and none of them are consistent, and some of them are horrendously complicated. Like it's like, you've got to generate this key and then you go on the website and give us the key and then we give you back a PEM file and then you've got to install the PEM file locally and then you've got to put this other key here and you can only connect when there's a full moon, and it's like, why does this have to be so hard? Like, and there's always the providers that end up with security vulnerabilities as well, ironically. But that's the tricky thing is trying to make this stuff consistent. I think we're kind of fighting a battle to some extent. But for places where it doesn't make sense, like VPCs, then you just set it up directly in the base driver. Or if you want to use anything that we don't provide, then use Blotto, use Nova Client if you're on OpenStack. It makes sense.
So do you know if people use LibCloud for abstracting the APIs of a single cloud provider, even if they don't have any intention of using a different platform, maybe just because the APIs of their provider aren't as intuitive as the ones that they're trying to use, or maybe their provider doesn't actually have a Python library for using it?
Yeah, definitely. This does come up. There are plenty of users that, like you say, the provider doesn't offer a Python library, or the Python library that they created was a port from another language and it was auto-generated code or just really horribly written Python. Or actually more common is that they have a Python library, but it only works with 2.6 or 2.7 and they want to work with 3. So actually our package is a good way of talking to these different cloud providers in Python 3.
And do you think that people are more likely to use LibCloud for bridging across multiple public cloud platforms, or do you think it's more commonly used in a hybrid cloud type of environment, maybe for people running a private and public OpenStack or a private OpenStack and bursting into public AWS or something like that?
I think multiple public cloud is the most popular. Going off a couple of data points for this, there's a survey that's done every year by a company called Whitescale that does multi-cloud management software, and they run a report called the State of the Cloud, and there's a lot of stuff in there about multi-cloud and abstractions, which is really useful for us to get a picture of how many people are doing multiple clouds. And multiple publics seems to be quite popular. The hybrid idea is, in theory, it's a really cool use case that people have a private cloud locally and then they burst to the public cloud and they've automated all of that stuff. In reality, what happens is that the way they define hybrid is that they've got this legacy, vCenter installation, and everyone goes in through the UI, like everyone logs in through the vCenter UI, and then they have like an AWS or an Azure, and they want to orchestrate and automate the public cloud stuff because they know how to do that. We do support VMware vSphere, but actually the number of people who do that is quite small because just maintaining that and orchestrating VMware is still a bit of a challenge. Their APIs are pretty complicated, and they were kind of written in a pre-Rust era. So
I also think you kind of alluded to this, but I think it's worth just saying out and out that hybrid cloud is one of those things that the idea is really attractive. It's like, okay, great, we get fault tolerance. But when the rubber hits the road, actually implementing it is very, very difficult. A lot of people say, yes, let's go do this thing. And then they actually dig into what's going to be required to make it happen. And the reality is not so rosy.
Definitely. I'm hoping containers make that easier. I know containers is the answer to everything these days, but yeah, it's like this doesn't have enough containers, so we'll just put some in there. But I'm hoping that does make it easier because you focus less on the infrastructure automation and you just focus on the application piece. So
I think it'll make some problems more tractable. I think it'll make the sort of how do you define a software image problem that you used to have, like, you have to build an AMI and then you have to build an Azure image, then you have to build a GCE image. Those kinds of things are made easier by containers because it's like, yeah, you build a Docker container and you can deploy it everywhere. But it doesn't make things like, as you pointed out earlier, the radically different authentication schemes and the differences around how networking is handled and how various other aspects of security are handled. It's those devilish little details that I think can make this kind of project go from, oh, this should be easy to, my goodness, maybe not so much.
Yeah, and the container ecosystem is still growing. So Docker is the big player right now, but there's also the Rocket project from CoreOS that's starting to gain ground, and also there's native LXC or BSD jails that have been around for quite a while now, so the choice of which one to use is still something that requires some consideration, and also things like the security of the images that you're pulling down for being able to layer on top of, or also this is something that's been solved a bit more now than it was when Docker first came out, but the inter-container networking has something to consider. So you're just trading off for a different set of problems. So as in everything, it's trade-offs.
Yeah, so we did actually add container as a service, like a base driver for container as a service. It's still experimental at the moment. So we're just waiting for a bit more feedback and also for some of the APIs that we're calling to stabilize. So the idea with it was that people have these Docker images, these Docker containers that they've constructed, and they want to deploy them, they want to test them locally, and then they want to either deploy them into a private, like a Kubernetes deployment, or they want to use one of the public clouds that supports containers. So Amazon have ECS, their Elastic EC2 container service, and Google have their public cloud version of Kubernetes, so GKE, I think it's called. So what we did is provide an abstraction over those services. So if you go on a read the docs site and you click on the container piece, it's actually quite an interesting insight into the sort of current state of the container APIs. So similar principle to what you get with the compute, you can get a container as a service driver, and then you can install images and deploy containers into that. And we have a set of base classes for things like a container image and a running container and a container cluster. So Kubernetes and ECS support this notion of a group of containers or a cluster of containers. So you can create and destroy and list clusters and find out what containers are deployed in each cluster. And there's also if you go and dig around on the site, you'll find some example code. And I believe we're the first people to do this, where you can deploy Docker containers in Kubernetes, or you can deploy them in Amazon ECS, for example. And you can do that using the same code. So you can go and say, I want to deploy these instances and I want to go and deploy them over here as well. So you can write that and abstract that across. You mentioned CoreOS, their Rocket engine. We looked into adding that, but digging into the REST API, there's a big comment in the API source code that says don't use this. So I sort of thought, I think I'll stay away from this for a while and wait till it's stabilized.
So what is on the roadmap for LibCloud that people should keep an eye out for?
Yeah, so I mentioned the container driver support. So that's, we're looking to stabilize that based on community feedback over the next few months. So there'll be a stable version of that coming out soon. We had our own HTTP library that we wrote, Tamaz wrote, I think, back in 2009. This is before requests would have existed. And there are a number of reasons why that was put together, but for lack of a nice HTTP client that worked across Python 2 and Python 3, we ended up having to write our own. So we're replacing that with the request library, and that work has just been finished. So there's a branch version of that on our GitHub page, And there was just a blog post about that actually done today, explaining what the differences are and the reasoning behind it and what kind of advantages you get in having requests in play. So if you want to go and try that out, then that'd be great. Check that your code isn't broken, because when I put it together, we have just over 6,000 unit tests in the project, and I broke 4,500 of them in the first tranche of commits. So it basically took me a week to fix all of the tests.
Yeah, that's always fun when you make the change and have to try and figure out, okay, what is the common thing among all of these broken tests?
Yeah, it turns out to be about 20 different common things.
Yeah.
So that was quite a painful exercise, but it's done now. So I know that all the tests pass. However, I don't know whether the tests are valid because some of the underlying implementation has changed. So really what we need is proper testing.
So are there any questions that we didn't ask that you think we should have, or anything else that you want to bring up before we move on?
No, I think that's a great range of questions.
Okay, so for anybody who wants to keep in touch with you and follow what you're up to, what would be the best way for them to do that?
Yeah, so you can follow me on Twitter. I'm Anthony P.J. Shaw, or on GitHub, I'm Tony Baloney like the sausage. Or if you just want to follow us on GitHub, it's github.com/Apache/LibCloud. Oh, and I should also mention, if you're going to the SaltStack conference this month in Salt Lake City, I'll be there, and I'm speaking on one of the days about, not just about Salt Cloud, I'm talking about ServiceNow integration. But if you're going and you want to have a chat, just hit me up on Twitter, and I'd love to have a drink and find out what are you doing. Or if you're going to ApacheCon in Vancouver in May, I'm also speaking at that event. So again, if you go into that, then just send me a line.
So with that, we will move on into the picks. And my first pick today is going to be the Blue Yeti microphone, which I just picked up and I'm actually using to record this episode. So we've had a few comments about our audio quality, so I decided to pick it up, and hopefully it's having a positive impact. And for my second and last pick today, I'm going to choose the Diablo Swing Orchestra. So this is a group that I just found on Spotify a couple days ago, and they're very eclectic and interesting. So they're sort of a mix between jazz, swing, metal, and a few other things. So definitely worth taking a look at. They're pretty talented and pretty diverse. So a lot of fun, and hopefully you enjoy it. And with that, I'll pass it to you, Chris.
Thanks, Tobias. My first pick is going to be something that is unglorious, but oh so useful if you need it. The Rosewill RK series keycaps. I had the bright idea of buying a DOS keyboard that has no legends on the keycaps, which was just fine mostly for me because I touch type, but then led to a couple of really awkward moments when my wife and or other friends came over to the house and wanted to use my computer and couldn't because they can't touch type. So this set is a really nice, very inexpensive, you can get it on Amazon or from Newegg, I think it's their house brand, set of keycaps, and it comes with a keycap puller. So it's actually been relatively easy and actually kind of therapeutic to sit here and replace all the keycaps on this keyboard so that other people can use it. And I have to also admit that even myself as a touch typist, occasionally when it's like, okay, type Shift F10, I end up having to count function keys to hit the right key, and that is just a drag. So this thing's been great. My next pick is going to be a relatively new mobile application called Enki, E-N-K-I. And obviously I'll put links in the show notes. But this is kind of interesting. They're sort of in beta at the moment. You have to sign up and ask for an invitation. But I jumped on it early, so I got one. It's really kind of neat. It's basically an application for your phone they refer to it as developer training. So it's kind of like you get these little daily doses of training exercises, really sort of quick hit kind of things on topics like JavaScript, Git, CSS, Linux, et cetera, and I found it to be really kind of very satisfying, and it only really does, it actually really only does take just a couple of minutes to do, and it really has sort of, I consider myself to be a fairly well-versed Git user, and I've started out with the Git training session, and I've learned a lot. So that's been really great. My next and last pick is going to be a novel that is a classic, and I have no idea how I had not managed to not read it yet, being 47 years old. But Catch-22, it's a really sort of, it's one of those things that, you don't realize how many things tie into it until you read it, and then a bunch of cultural references come to light. It's a really great book. That's all I have for picks. Anthony, what do you have for us?
Yeah, I'll vouch for the Catch-22, mainly for the reason that whenever people say, "Oh, this is a Catch-22," you can say, "No, it's not." It's like the most misused thing ever. I have a few picks for you. On the non-technical side, I'm a bit of a podcast junkie, and one I'm particularly favourite at the moment is an NPR podcast called Hidden Brain. If you can dig this one out, it's about 20, 30 minutes long, the episodes. It's basically like a social psychology podcast, which kind of sounds a bit bizarre, but they kind of cover off all sorts of ideas like risk and fear and ego and all sorts of things. And it's just really interesting to hear the scientific explanations for sort of day-to-day challenges and issues, and what might be affecting you in terms of relationships with other people. And I found it really useful just to understand what the current thinking is in terms of the social sciences, and also to actually apply some of this stuff in my day-to-day life. So that's been quite fun. On the technical side, there's a Python package called PyQualify, Qualify, Kwalify. And if you're using YAML for like configuration of your project or defining things or whatever, it's really cool because YAML is so easy to write and it's human readable, but you've maybe lost some of that checking. So if you want to do static checking of YAML files, so for whatever reason, like let's say you've got a config file in your project, and every time somebody edits it and checks it into the build, you might want to run a check on the build and make sure that is actually valid. So you can use PyQualify to define like a schema, like a YAML schema, and you can validate your YAML files against the schema. So that's come in really helpful for me doing some testing. And my final pick is maybe slightly unusual. And if you're anything like myself, you find that you feel every minute of every day doing something. So whether that's like checking your phone, looking at Twitter, emails, Facebook, listening to podcasts, which is never a bad thing, but it does consume a lot of my time. My pick is actually doing nothing. And this is quite a skill that you need to practice over a period of time, which is just trying to find time in the day to not be doing something and not be learning something, to actually try and focus on doing absolutely nothing. And there's a few ways that you can do this. Things like watching the kettle boil or watching the bath run, or it's really soothing and it kind of gives you some time to reflect on things and some time to think about things. Another way you can do it is a technique called mindfulness, which is becoming a bit of a hipster thing at the moment, but it does actually have some sort of more serious side. And there's an app you can get called Smiling Mind, which probably goes against my point of not doing anything, but it's like an audio guide that helps you through like meditation technique and learning to relax. So if you find yourself over eager and fidgety and you're struggling to sleep, then I strongly recommend that.
All right. Well, thank you very much for taking time out of your evening to join us and tell us more about the LibCloud project. It's been a lot of fun, and I learned a few things about it that I never knew before. So appreciate that, and I'm sure our listeners will as well. So thank you, and enjoy the rest of your evening.